So now that we've defined what an angle is and we've begun classifying these angles, I'm going to bring our attention back to something you may have picked up on or not. If not, that's okay. But you can see some of the benchmarks for how we defined angles. A lot of them were centered around these two particular angles, 90 degrees and 180 degrees. These were particular benchmarks for defining these ones. So for acute, that was centered around the angle's relation to 90 degrees, between 90 degrees and zero. An obtuse angle was between 90 degrees and 180, and a reflex was greater than 180. So these are two quite significant pillars in geometry, and angle geometry. So now we're going to begin to look at in some initial angle relationships. So we're going to look at this angle on the left that I've drawn, this 90-degree angle. Now, these are two lines that meet at a particular vertex. So let's call, I'm going to label each side of my line. So I have A, B is the vertex, and C. Now I'm going to draw another line here. So let's chuck this one in. Oh, that's not what I want. Please work. Here we go. Sorry about that. Now, what if I joined this other line to my vertex? And I'm going to call this side D. So I've brought out this line here. Now, this line, it intersects, doesn't it? It meets at the same vertex as our two initial lines. Now, what you may have noticed is that by adding this line, we originally had just our 90-degree angle. Could it be safe to say that I have added two new angles here? I have this one here, and I'm going to just do a little blue dot just to show that that's the angle that I'm thinking of. And I'm also going to draw this one here. We've created two angles that from this extra line that we've added. So let's think for a minute. Our original angle was 90 degrees, and now we essentially have two new angles. Can we think what they might sum up to? We don't know what they are. These are just random dots I've drawn that we have no values for them. So we don't know what each angle is, but do we know what the sum of these can be? Now, if I take this line, I'll let you meditate on that for a minute, but if I take this line and I move it somewhere, right? So I'm just going to rub these out. No matter where I move this line, could we say that both of these angles will always add up to 90 degrees? Say I had it here. My blue angle, I'll start with my green. My green angle becomes a lot bigger because it's moved closer to 90. And my blue angle is quite a bit smaller. But they still add up to 90 degrees, don't they? Because they make up, them two together, their sum makes up 90 degrees. Here. What if I went the other way, right? What if, let's say, I move my line, if it works. Sorry, it's going to be really finicky sometimes, but if I move my line somewhere else, down here, for example. We can see the blue angle I had to the left, that's increasing as the green angle decreases. So there's this constant back and forth between our angle sum no matter where we go. Say here, my blue angle now is huge relative to the size of my green angle. But it's almost like this power play, isn't it? Because as one angle increases, the other decreases. There's a balance there, right? And as the other increases, our first one will decrease. And as we move, as we move in either direction, their values change, but their sum never changes. Their sum is always 90 degrees wherever we go. And we have a special type of name for these angles. We call these complementary angles. And we're going to have a lot of really big words, so don't get too discouraged. It may feel like an English lesson, but we have some big words in maths that we use. We call these complementary angles. And I'm just going to write this little, we can use this sign to denote an angle. And these complementary angles, they add up from what we've observed to 90 degrees. And even if I added a line here, if I added this line here, now we have 3 angles. Now we have 4 angles. Now we have 5. Am I counting that right? Yes. Now we have 6. We've just divvied up the angle sizes. So we have a lot of smaller angles here. 1, 2, 3, 4, 5, 6. But they all still make up this 90-degree space. They are always adding up to 90 degrees. And no matter how many we put, we will still see this relationship where they will add up to 90 degrees. And the same thing happens when we have a straight line. So let's call this A. You don't really see it, but there is a vertex here of B and C. And if I draw another line, say here, to the vertex, we get the same thing, don't we? As one angle increases, we've made 2 angles here. So the angle from the right-hand side, and to use some of the terminology, we have this acute angle on the right and this obtuse angle on the left. And the acute's getting bigger, the obtuse is getting smaller. Oh, here they're at 90 degrees each, because this is halfway. And we have this balance of power that shifts. Now my left one is acute and my right angle is obtuse. And these are constantly adding up to 180 degrees. Now, once again, I'm going to label this side D, or this part of the line. And we can say, actually, I'm gonna write a bit of mathematical angle notation to get you used to writing these. But in my left-hand side, when we write angles, because I want to show this angle here. So I'm going to write this angle sign. I'm going to write D, which is one point, one vertex. Have B, which is the middle one, and C. This tells me clearly, and I could have written this as CBD. The order doesn't matter as long as the angle that as long as the point that both lines are meeting at is in the middle. This tells us exactly that we're looking at this angle here, D, B, C, there. Now we can write here in angle notation the DBC plus, let's call this ABD to show you that whichever way we write it, doesn't matter as long as this is in the middle. We can say that DBC plus ABD equals to 90 degrees. And same thing here. And no matter how big or small our angles DBC or ABD get, they'll always add up to 90 degrees. Same thing here. These particular angles, so we've observed the same thing happening, whether we no matter how many angles we add, we're always going to get all of these adding up to 180 degrees because they make up this space from here to here. So clear some of this. And we're going to define these now as, we call these supplementary angles. Another big word, unfortunately. Supplementary angles. I really hope I've spelled that right. Supplementary angles. And these add up to 180 degrees. So, formalizing this using angle notation, well, we have once again that DBC, this angle on the right-hand side, plus angle ABD, these add up to 180 degrees. These are the first two angle relationships we're going to work with. And knowing that what these add up to, we don't know what they are, but we know what they add up to. And that is very powerful in terms of solving certain unknowns. Now, let me give you one example before we wrap up today. Say I have a right angle here, and we know that because I've told you. And let's say, well, I don't have to write 90 because this little right angle sign tells you that that's 90 degrees. And I'm going to draw a line from here to here. Okay. I'm going to tell you that this angle, you do these in all different colors, that this angle here is 30 degrees. I know that it's a smaller one, so this angle clearly, just visually, it looks a bit bigger. So we'd expect this to be roughly 30 degrees. Now, we don't know what this angle here is. And I'm going to call that X degrees. This is some unknown. We don't know what X is, but from our complementary angles, which we know that these add up to 90 degrees, we have this relationship that we know that X plus 30 degrees equals to 90 degrees. Why do we know that? Because these are comp for complementary angles. So we need some number that when added to 30 gives us 90. And if you had a go at this, that is awesome. And I'm going to give you the answer here. We know therefore X should be 60 degrees. So that is these are the first two angle relationships we're going to be dealing with: complementary and supplementary. And you'll probably have questions in your exercise book, which they can get more complex for sure. We can add all these extra lines like we did before in our two diagrams, but these questions are no longer that scary to us, because when we are looking for an unknown value, we can always consult the fundamental knowledge of these angle relationships, which is that for complementary angles, these 2 or 3 or 4, etc., will always add up to 90 degrees. Same with our supplementary angles. We'll keep working through further examples of angle relationships in the following videos. See you there.